Okay, so let's get into internal energy. Okay? So we are going to use the letter U for internal energy. Okay, so I know I used a bunch of different letters for energy previously. In the thermal world, U is the internal energy. Okay? And so remember this delta, right? This delta gives me final minus initial. But also don't forget about state functions, right? So state functions are always represented by capital letters, always. And a state function is path independent, okay? So that means we only care about the final state and the initial state. We don't care about what happened in between. And there's this rather cute picture I like to draw of the USA. So suppose you're here, like maybe somewhere in Colorado, beautiful mountains and forests and trees and stuff, okay? And you get on a plane and you want to travel to Chicago, okay? Well, as viewed by a state function, Denver would be somewhere around here, right? At like, 1 mile above sea level. And, here's Chicago, a bunch of awesome buildings, formerly the tallest building in the world, Sears Tower. Navy Pier with the Ferris wheel. That's right, that's a Ferris wheel. Bunch of brick houses with chimneys. Yay. Okay, so this is Chicago, Chi-Town. Okay, so suppose now we take several different paths. You want to travel between Denver and Chicago, right? And suppose you just drive there directly. So you take this path A, okay, where here's your initial state and here's your final state. Great, okay? Suppose now instead of driving, you take an airplane. Okay, so you get an airplane and you go, and then you land at O'Hare. Fantastic. Okay, initial and final. So you still made it to the same place, whether you drove or you fly. Suppose you're feeling really crazy and you want to go on a round the trip world. So this is like going all the way around the world. Okay? And you still end up in Chicago. If your change in elevation between Denver and Chicago is a state function, then it does not matter which path you took. Okay? So if we think of, let's say, like our internal energy initially and our internal energy finally, notice in this state function, there's nothing that says what path we took. Now, undoubtedly, if we were talking about the work that we did, all of these paths would have very different amounts of work done. Okay? And so I'll back up for just a second and show you, look, work, lowercase w, not a state function. Energy, big capital U, state function. Also, look at this, heat, lowercase q, not a state function. Okay, so let's write that down. Heat is a path function. Energy is a state function. Work is also, like heat, a path function. Okay? So, capital letters get capital letters get state functions, and often when we can simply just say the change, right, in internal energy, then we know that we're dealing with a state function if we only care about the final minus the initial, okay? And so if we just look at energy in terms of joules, so that's the intensive parameter, but if we look at molar internal energy, UM, which is U divided by N, that's going to be our extensive parameter. And we'll often see this molar internal energy because that gives us one less parameter to deal with, right? We can reduce our variable space by just absorbing the number of moles into that term, okay? Great, so let's keep moving on.